Hello friends, my name is Assistant Professor Samir Kole. So welcome to my YouTube channel. Today we will see the next topic of 8051, which is called as internal RAM organization. So on the screen you can see the diagram of internal RAM organization. This internal RAM organization consists of 4 banks, that is bank 0, bank 1, bank 2, bank 3. Then it has bit addressable area and it also has general purpose RAM. So internal RAM organization, if you consider, internal RAM is total of 128 bytes. So in 8051, internal RAM is of 128 bytes, and these 128 bytes are divided into these different groups. So by default, upon when you reset the microcontroller, bank 0 is selected. So by default, register bank is called as bank 0. So initially there are lower 32 bits there are lower 32 bytes of internal RAM organizations, which are divided into 4 register banks, that is bank 0, bank 1, bank 2 and bank 3. In bank 0 we have 8 general purpose registers. So 8 general purpose registers are from R0 to R7. Each register has a word size of 8 bits. Okay, so address of bank 0 is from 00H to 07H. Then next location we have bank 1. Bank 1 is again same, and its address locations is from 08 to 0FH over here. So in all this, total 32 bytes are being considered for bank locations. These banks can be used for stack purpose, means whenever we are using any stack memory location, stack pointer is used over here, and whenever you want to push or pop any data in this internal RAM, you can use this by default bank selection. So this bank selection is dependent upon 2 bits. These 2 bits are given in PSW registers. So bit number 3 and bit number 4. Bit number 3 is RS0 and bit number 4 is RS1. So whenever you give this combination as 00, means RS0 is equals to 0 and RS1 is equals to 0, you get bank 0. So by default, as I told, whenever you reset the microcontroller, bank 0 is by default selected. Then when you give the combination as 01, bank 1 can be selected. When you give the combination as 10, bank 2 can be selected. And whenever you give the combination as 11, bank 3 can be selected. Also, initially when you reset the microcontroller, the stack is initialized at the address 07H. Okay, so stack is initialized at the address 07H. So whenever you push the data on the stack pointer will always initialize the location which is 08H, which is from the bank 1. So by default, initialization address of the stack is 07H, and whenever you push the first data on the stack memory, it will be pushed on the location 08H, that is at the address location 08H. So you remember that always the stack is initialized at the address 07H, and whenever you push the data on the stack, so that data is pushed at the first location, which is 08H. Next we have 16 bytes. So after lower 32 bytes are being given to this 4 bank selection, then we have 16 bytes. These 16 bytes of data is called as bit addressable area. Means here you can do bit addressing. So general instructions of assembly like set bit, clear or complement can be used for the bit addressing area. So instructions like set bit, then clear instructions and complement, which is CPL, can be used for single purpose instructions. So in this bit addressable area, you can do bit addressing, that is you can check the single bit status by using this bit addressable area. And this bit addressable area is of total of 16 bytes, and it starts from the location 20H to 2FH. So it starts from the location 20H to 2FH. Then at last, remaining we have general purpose RAM. This general purpose RAM is from address locations 30H to 7FH. General purpose RAM is at address location 30H to 7FH. So general purpose RAM means what? This area is being given by the manufacturer to the user, means here you can just do anything. So this is a general purpose RAM and its location is 30H to 7FH. So approximately if you consider it is of 80 bytes, so 80 bytes of RAM area is being allocated to the user and you can just do anything over here. Okay, so once again we will just shortly revise this condition about internal RAM organization. Internal RAM organization is total sizes of 128 bytes. It has 4 register banks. Bank 0 is by default selected whenever you reset the microcontroller. Then stack is initialized at the address 07H, and whenever you push the first data on the stack, so this data is always at the address location 08H. Then next point is about the selection of bank. Instead of bank 0, if you want to use bank 1, bank 2 or bank 3, then you can use them by giving the combination at the 2 bits RS0 and RS1 which are present in the PSW register. PSW register is program status word. So RS0 is bit 3 and RS1 is bit 4. So when you give 0-0 combination, bank 0 is by default already selected. 0-1 if you give the combination, it is bank 1. 1-0 if you give the combination, then it is bank 2, and 1-1 when you give the combination, it is bank 3. Then after lower 32 bytes have been consumed, we have 16 bytes which are given at the bit addressable area. So bit addressable area is considered as 16 bytes and its location is from 20H to 2FH. Okay, so in bit addressable area you can do general purpose single bit instructions like set B, clear or complement instructions. Then we have at last general purpose RAM. So this general purpose RAM is of 80 bytes and its address location is from 30H to 7FH. So general purpose RAM is being given to the user, so the user can do just anything over here. So you can use this general purpose RAM of 80 bytes for your any purpose of programming in the microcontroller. I hope you must have liked about this internal RAM organization. So I would like that you just subscribe my channel, and thank you so much for watching the video.